In this video, I'll be explaining the chain rule, and I'll be doing various practice problems. So before I start, we should know the general formula of the chain rule. So let's say we have some function, f of g of x. Its derivative is equal to the derivative of the outside function, which is f prime, the outside function, and its inside function, multiplied by the derivative of the inside function, so g prime of x. So this is the general formula for the chain rule, and this is what we'll use to do some of the problems. So for this first problem, we're asked to find the derivative of y equals cos of x cubed, and we know we have to use the chain rule for this because it is a function cos, and the outside function is cos, and the inside function is x cubed. So we're not multiplying these two together. It's not cos times x cubed, it's cos of x cubed. So we know how we have to use a chain rule on this. So to start this derivative, we take the derivative of the outside function cos of x, because that's what the formula states. We take the derivative of the outside function, and the derivative of cos is minus sine. And we have to write of x cubed because we keep the original inside function the same, but then we have to multiply by the derivative of the inside function. So the inside function is x cubed, so we have to multiply by its derivative, which is 3x squared. An analogy for the chain rule is peeling an onion, because when you're peeling an onion, you're taking off the outside layers before you get to the inside layers, and the chain rule is the same. You have to take the derivative of the outside function before you take the derivative of the inside function. So to help you remember, just remember peeling an onion is similar to the chain rule. Okay, let's do another example. So this time, let's differentiate or find the derivative of y equals sine of the square root of x. So the first thing that we want to do is take the derivative of the outside function. So the outside function is sine, and the derivative of sine is cosine. And we keep that inside function the same, so square root of x, and we multiply it by the derivative of the inside function, which is square root of x. And to find the derivative of the square root of x, we know that the square root of x is equal to x to the power of 1/2. So the derivative of x to the 1/2 is 1/2. We bring down the exponent, multiplied by x, and we subtract 1/2 by 1, so it gives us this as the derivative. So we can say we multiply by this. So this is the derivative for sine of the square root of x. Okay, this time let's do an example that is slightly different than these two that I've done so far. So this one asks us to differentiate y equals 2x cubed plus 5 all to the power of 4. So in order to do this, we have to look at the other formula that I have written down. So this says that the derivative of a function to the power of n, its derivative is equal to the n brought down, so we bring the n down. So this is essentially the power rule. We bring the n down and we multiply it by the inside function, which is f of x, and we subtract the n, the power of n, by 1. And then we multiply it by the derivative of the inside function. So it's essentially a mixture of the power rule and the chain rule. So here I will apply it to this problem. So y prime, we bring down the power, so 4, we multiply it by the inside function, which we keep the same, and then we subtract the power by 1, so 4 minus 1 is 3, and we multiply that by the inside function, the derivative of the inside function, I should say, which is 6x squared, because the derivative of 2x cubed is 6x squared, and the derivative of 5 is 0. So this is the derivative. Okay, let's do another example. So this time, we are asked to differentiate y equals the square root of sine of x. So we know that the square root of sine of x is the same as writing, sine of x all to the power of 1/2. It's just another way of writing it. Knowing this, we can easily find the derivative using the chain rule. So we take down the power 1/2. We keep the inside function the same. We subtract 1 from 1/2, which is minus 1/2, and we multiply by the derivative of the inside function, which is sine of x, to give us cos of x, and that's the answer. Okay, let's do a couple more examples. So, this time we are asked to differentiate f of x equals x squared plus 1 cubed times x squared plus 2 to the power of 6. So this question is a little bit more challenging because we have two things multiplying each other, which means we also have to use the product rule, and that complicates this question a little bit more. So the first thing that we do is we find the derivative of the first function. So derivative of the first function is we bring down the 3 and we multiply that by the inside function, which is x squared plus 1. We bring down the power from 3 to 2 because we have to subtract it by 1. And then what we have to do is we have to multiply it by the derivative of the inside function. So the derivative of the inside function here is just 2x. And we can write that all in brackets. And then we have to multiply this by the other function we have here, x squared plus 2 to the power of 6, because we are doing the product rule, and the product rule states that we have to multiply by f prime of x, and then we have to keep g of x, and then we have to write plus f of x times g prime of x. So that's what I'm going to be doing here. But to find the derivatives, we have to use the chain rule. So that's why this is a complicated problem. So we have to add that to the regular function f of x here, which is x squared plus 1 cubed, and we have to multiply that by the derivative of the other function, x squared plus 2 to the power of 6. So to do that derivative, we take the 6 down, so 6, and we write the inside function, x squared plus 2, and we drop the exponent by 1, and that gives us the power of 5, and we have to chain the inside function. We find the derivative of the inside function, which gives us 2x. So this is the derivative for this function. Okay, let's do one last example. So this question asks us to differentiate y equals sine of tan of 2x. So this example really tests your understanding of the chain rule to see if you actually understand the concept. Because what we have here is we have a function, sine, and we have a function inside of it, tan of 2x. So we have a function inside of a function. And we have to use the chain rule twice here for this answer. for this question. So to start it, we find the derivative of the outside as always, and the derivative of sine is cosine, and we keep the inside function the same, so tan of 2x remains the same. Okay, now that we've tackled the outside function, we can tackle the inside function. So what is the derivative of tan of 2x? Or just tan, I should say. The derivative of tan is secant squared. And we have to keep the inside function here, the 2x, the same. So once we've done that, we can find the derivative of the inside function here, 2x. And the derivative of 2x is 2. So for this one, you have to work through each outside function before you get to the final inside function. If you enjoyed this video or found it helpful, please subscribe, and don't forget to turn on the notification bell so you don't miss more of my videos.